Hello, my name is Hanan Omar Sais. I'm a senior at Yusra International Schools here in Jeddah, and I am driven to assist in sustaining our balanced environment. Before I start talking about my project, I would like to share with you two photos. So, this is how our beloved home looks like at the present time. However, this will be its future. An Earth with rising ocean levels, deforestation, no ice caps, endangered animals and plants. But there is a way to prevent this fate. How, do you ask? By finding ways to effectively address our environmental crisis, which is mainly caused by the release of CO2. Unfortunately, as of now, CO2 emissions have risen by almost 90% since the 1970s. Consequently, we are in need of innovative, clean approaches to generating renewable energy and reducing CO2 levels, as CO2 reduction is energy intensive and is currently accomplished by burning fuels, which in turn releases more greenhouse gases. Having that said, my project expands on the renewable energy resources used to actively remove CO2 from the atmosphere and convert it to value added chemical stocks such as formic acid without emitting CO2. Further, this is to be done by piezo-electrocatalysis, a tandem process between piezoelectricity and electrocatalysis, where piezoelectricity is responsible for producing enough piezopotential to meet the needed electrocatalytic process. In my research, I and my mentor investigated the feasibility of using piezoelectricity harvested through pressure produced from falling raindrops on piezoelectric transducers similar to the one shown here. We first started by preparing the bismuth catalyst and testing how effective and selective it is as a catalyst in the reduction of CO2 to formic acid. And as evident here from these graphs, the linear sweep voltammetry graph and the Faradic efficiency graph and the chronoamperometry graph, it showed efficiency and selectivity. Next, we prepared the rain simulator shown here. Then we prepared the piezoelectric convergence circuit shown in figure 7 and tested the piezoelectric transducer used in this experiment for proper function, gauged and also gauged the voltage and current to ensure the potential barrier will be overcome. After that, we prepared the electrochemical cell shown in figure 8, where H2O oxidation took place in the anode with platinum as the catalyst and CO2 reduction in the cathode with bismuth as the catalyst, and then we connected the various parts of the experimental setup. Following that, the experiment was run for several hours as CO2 was periodically pumped into the reactor. And as can be seen here in figure 9, voltage and current produced reached levels of 2.5, surpassing the barrier of 1.5 volts. Finally, samples from the reactor were gathered and analyzed. And as can be seen here, a peak at the chemical shift of around 8.44 was reached, proving a moderate amount of formic acid was produced. In conclusion, we proposed and proved the feasibility of a novel method of reducing CO2 to formic acid utilizing energy harvested from raindrops. And as for future work, we aim to improve this process efficiency and we aim to improve the rain simulator so it better resembles real life situations, and we also aim to test different sources of pressure other than raindrops and to produce different organic compounds other than formic acid. And that's it. Thank you so much for your attentive listening, and I hope that you and I get to pave the way for a more sustainable future.